I didn't think the math was that hard that you would need a calculator.
Just don't. I'm lazy. Yeah. Since we got this class, we've been really lazy on calculations.
Jenna, we're taking the quiz. It's live right now. You should be able to see it.
Okay, wait. I don't want to divide that.
All right, we're gonna go to silence now.
I'm not lazy. I'm tactical.
All right, we're gonna be quiet. Come on.
Yes, sir.
Matt, hurry up. You're using all your time. Mm-hmm.
Research.
After him. cadence. And tomorrow I need you for 6th and 7th. I'm sorry, for 5th period to set up the volume. You know what to do for all that jazz? Okay. I talked to Miss Allen yesterday. She said you would know what to do and all the stuff. I don't know if it's going to be locked or something like that, but Miss Grenier will be up with it as well too. So you can find the key. How many people do you need to help you with that? Figure out who you need.
So 5th period.
Yeah, so 5th period, we're going to go down there. And it's going to be 9th grade against 10th grade volleyball. How long does it take to set it up?
A couple.
Okay, good. Cool. Okay, 5 minutes left.
All right, 1 minute. All right, let me have that. Make sure your name's wrong. So look to me like majority of the class was done in about 6 minutes. That's a good thing. And Chris spent 6 minutes drawing tanks on it. Very nice man. Yes. So. Confident on this stuff?
Yes.
Yeah. All right. I mean, it all turns into an algebra problem. So, you know, as long as you set up the algebra problem correct, if you made a silly mistake, you get many of the points. Not most of the points, but many of the points. You set it up incorrectly, then I'm going to take most of the points away. Yeah. Say again? Sure. All right. Questions on last night's homework? Oh, by the way, it was the worksheet. I'm going to choose not to collect it because you had the answers. Yeah. Just so that you have visibility, this is the first up or 9th and 10th grade class I had. Tomorrow, what it's going to look like, e-learners, Jenna, we're going to, if we can make it happen, we're going to live Zoom the presentations tomorrow as well too. So we'll send you guys an email, e-learners, tonight or tomorrow morning at some time with the Zoom links for those particular meetings. We're gonna do normal essay in the morning, normal assembly, and then we run periods 1 through 7. So every period you'll have a new speaker that you'll listen to. So, you know, take it for what it's worth. If it's someone that talks about something like, I don't ever want to do that, that's fine. Just listen to their story about what they do and use that as research or information that helps you guide your decision making or whatever you want to do in life type thing. Their stories about what they did in college or what they did to get to their career certainly have applications, even if you don't want to be what they want to be. At least it'll broaden your horizons, so to speak, of what you need to be thinking about. So periods 1 through 4 are just going to be speakers, selected speakers. This won't be the only thing we ever do it, you know, this year for you guys for career stuff. We're going to do much more stuff for you to help you along that decision path. Period 5, we're going to take a break. Cadence is going to set the volleyball net, and we're going to have a 9th grade against 10th grade volleyball tournament. Right, so it's going to be about 30 minutes or so. It's a 37-minute class, so we got about, you know, maybe 25 to 30 minutes when you play volleyball. So we'll play volleyball 5th period, then we'll eat lunch. And then 6th and 7th, it's going to be Miss Hammond, who's the college counselor, is going to talk you through what you should be doing sophomore year to get ready for a career in college, or what you need to be thinking about, what you need to be exploring. Just remember, these are all your decisions, right? Even though we're going to help you with some information, we'll help you with some research, right? Ultimately, it's your decision what you do. I mean, everything from, I'm not going to do anything, I'm done, right? And my parents are going to support me in the basement. Yeah, good luck with that. to that, I have some definite career paths to I want to go to college, or I want to go to trade school, or I want to immediately go out and get a job. I'm going to start a business. That's, entirely up to you guys what you do. But, it was a hard lesson for me to learn when I was your age, is that whether I wanted to make these decisions or not, they got to be made, right? Because time continues and time's going to catch up with you. If you haven't made a decision, well, then life's going to make that decision for you. Okay, enough of that speech. Wow, that's a weird thing. Why did I write it like that?
That's not okay.
Why did I write it like that? I could have written 1 through 12 all. I must have lost my mind that time.
You skipped 13 and then you skipped 16.
Yeah, but why didn't I just write 1 through 12 all? I don't know.
Oh, yeah. Skipping 10.2.
So I'm certainly skipping 13 and 16. It probably proves that we're going to do in class.
Yeah. You bring my locker now. So.
All right. Did you get a sheet? All right. That was probably it. Yeah. Today is there's a lot of stuff. All right. Class is over in 30-ish minutes. I'll get through it all, but there's a lot of stuff today. The cool thing about today is it's all stuff that you're very familiar with. But we're going to do it in a geometry mindset, meaning I'm going to get to specifics. I'm not going to talk about any shapes you don't already know. You probably know most of the things about the shapes I'm going to talk about. Maybe not the rhombus so much. But you already know lots of things about squares and rectangles. The way you do well on this material is that you understand the specifics about the shape and you take great notes. The actual, so what about it, the details, the skills, they're pretty simple. They're based upon the theorems that we'll go over today. We'll go over, I think, 3 theorems today. Maybe it's 2. It's either 2 or 3. There's 6 of them? There's 6 of them? I thought there were 3. Yeah, I'm not going to.
Oh, I almost forgot to write the page down.
187, 188. All right, here we go. All right, so special quadrilaterals. So I'm not sure why they're special, but most books call these the special quadrilaterals. It's going to be a tough day. Not maybe as tough as that guy's day, but it's going to be pretty tough. All right, have you ever seen the video where the guy jumps from the car into the cactus? Do not watch that on YouTube.
He is a man.
Right.
I look up to that kind of guy, those kind of guys.
They're idiots.
I know. Exactly. There's cactus in my walk home.
All these paramedics are trying not to laugh, is what they're really trying to do. All right, so the first one we're going to get is a rectangle. Write this down, please. Well, it is a quadrilateral. It means it has 4 sides. And by definition, not because it's some special thing of a theorem, we just say by definition, we're going to call anything that has 4 sides and 4 right angles, we're going to call that a rectangle. That's by definition. We don't prove that. We just accept that as a definition. You got 4 right angles, and you got 4 sides, you are called a rectangle. We get lots of new stuff about rectangles. But we also get the fact that a rectangle is actually and also a parallelogram. So if a rectangle is a parallelogram, we get those 4, it's technically 5 things. That's also true about parallelograms. Wes, give me one of them. If it's a parallelogram, then say again. Opposite sides are parallel. What else? That's 1 of 5. Go, Madison. Opposite angles are congruent. What else? Same side what?
Never mind.
What do you got, Cadence? Opposite sides are congruent. We're up to 3. What do you got? Go ahead, Karis. The diagonals bisect each other. 4, and there's one other. Consecutive angles are supplementary. So we get all those because it's a parallelogram. Okay? So the consequences, all rectangles are parallelogram. We can prove it's a parallelogram. Hey, opposite angles are congruent, therefore it's parallelogram. Okay? You could also prove it by 5, 6. Consecutive angles are supplementary. Okay, cool. Next one, rhombus. It's a lot of people say diamond. That's not a math term, but rhombus. It's the square that's not a square, right? Doesn't have right angles, right? Or I should say, not all plural rhombus is rhombi. Not all rhombi have right angles. Some of them do. We call them squares, right? But not all rhombi have right angles. All right, so a rhombus we define as a quadrilateral that has, say again? No, because it's not that it doesn't, it can, right? It has 4 congruent sides, okay? So a rhombus is a quadrilateral with 4 congruent sides. So a square is a rhombus, but not all rhombi are squares. Matt, is a rhombus a parallelogram? Okay, prove to me it's not a parallelogram. Are opposite sides congruent? It's a parallelogram. So, consequence, then it's a parallelogram. We just proved it. 5-4 says that if opposite sides are congruent, then it's a parallelogram, and we just did that. So all rhombi are parallelograms. So we get those 5 things. Opposite sides parallel, opposite sides are congruent, opposite angles are congruent, same side or consecutive angles are supplementary, and the one that are diagonals bisect each other. Rhombi parallelogram. Rectangles are parallelogram. There's a pattern forming for special quadrilaterals here. We good? All right, last one. That's not too bad. That is a, why is that a square, not a rhombus? It also has 4 right angles. So what makes a square unique, it is a rhombus that has 4 right angles, right? They choose not to say that. They choose instead to say a rectangle. So they say a rectangle with 4 congruent sides. I could also say it's a rhombus with 4 right angles. But a rectangle has 4 right angles. And if you are a rectangle and all the sides are congruent, then you are called a square. We'll try this again. That is a square parallelogram. Why? Opposite angles, he chose that one. You could also say opposite sides are congruent, any of those. So the 3 special quadrilaterals we did today were square, rhombus, and rectangle. And they're all parallelograms. So all the work we've done in the previous 3 lessons also apply to these 3 quadrilaterals. Okay, that's not too bad. If it was just this, we'd be fine. The issue is, and this is why I said, oh, look, there's 6 theorems here. The issue is that you get some other stuff. Not only do you have the 5 things because they're parallelograms, you get a lot more things because they have some special characteristics that we'll talk about here in a second. All right. So what was that all about? Seemed pretty easy, right? All squares, rectangles, and rhombi are parallelograms. So you get these 5 things: opposite sides, opposite angles, consecutive or supplementary, opposite sides are parallel, and the diagonals bisect each other. You guys all said that. Good job. Okay, not that bad, but right, you get lots more. Okay, so today's class is about the extra stuff. So this is going to be Theorem 512. I can't remember if I gave you this for homework. It's easily proven. Okay, in Theorem 512, make sure this goes in your book of truth. Theorem 512 says the following. We already know that diagonals, a rectangle is a parallelogram, so rectangles bisect each other. But just for rectangles, notice I didn't say for all parallelograms, just for rectangles, the diagonals are congruent to each other. Before we had the diagonals bisect each other. That's still true, right? But if you are a rectangle, by the way, squares are rectangle. If you are a rectangle, then the diagonals are congruent to each other. And you can kind of visually see that with this one, right? The diagonals look to be about the same. Very easily proven. set up two triangles, show me the diagonals congruent. So same drill that we always do. If this is the one I gave you, since I'm not proving it, I guess I did give it to you for homework. Set up two triangles, maybe this one and maybe that one. Show me why they're congruent. It's a parallelogram. Opposite sides are congruent. Opposite angles. Consecutive angles are supplementary. All that stuff we can use. Oh, it's a rectangle. So by definition, all the angles are 90 degrees. It's an easy one. I kind of just gave you the proof. We okay? So if you're a parallelogram, the diagonals bisect each other. But if you are a rectangle, which is a parallelogram, not only do you bisect each other, you are congruent to each other. All right. So this is true for rectangles, clearly, because that's what it says. But remember, squares are rectangles. So this is the key right here. We're not going to have another theorem that says, oh, if you're a square, the diagonals are congruent. We just have, say, the one that says for rectangles. But you also got to remember that squares are rectangles. So this theorem also applies to squares. Yeah? Danny, yes? Okay. All right, now let's do a proof. So I got a rhombus this time. So it says you have a rhombus with diagonals AC and DB, and we're going to try to prove that the diagonals are perpendicular to each other. Notice, this doesn't say I have a rectangle, it says I have a rhombus. So this will be true for rhombi, not true for rectangles. Also not true for all parallelograms. This will only be true for what things are rhombi. What things are rhombi? Rhombi and what's also a rhombus? Squares. So this will be true for rhombi and squares. All right, this one's not too bad if I tell you the hint. The hint is I need to show that this is perpendicular to this. There's lots of ways you can do it. The way I'm going to choose to do it, you see this triangle right here and this one right here? If you show that those two triangles are congruent, this one and this one, and then if you showed me that this angle is congruent to this angle because they are on a line, what would that mean? They're supplementary. So therefore, the only way you're congruent and supplementary is if you're both 90. That's how we're going to tackle this proof. So show me that this triangle is congruent to this one, and then call it CP-CTC, that this one's congruent to that one, and since they make we call it a linear pair, right? Two angles that make a line. If you're congruent and you're a linear pair, you must be perpendicular. Okay, that's the proof. Let's do it. What do you want?
They share the same size letter.
Okay, so what? AM is congruent to AM? Okay. Bailey's not here for me to call on. We'll go to Wes. He got it. Okay, so now we have that. So I got two sides. This would be the thinking. If you can come up with this one, I'm proud of you. Anybody? Micah? You're supposed to be thinking. I'm trying to get this triangle congruent to this one. We got this side and that side. So I got an S and an S. If I could get an angle, that would be good. If I could get another side, that would be good as well too. What do you got? Boom! Very impressed. Notice it's a parallelogram, rhombi or parallelogram, so diagonals bisect each other. So we could say that right there, and that's the trick to this one. Very good, I'm impressed. All right, so DM is congruent to BM. Why? Well, because it's parallelogram and diagonals bisect each other. Therefore, the two triangles are congruent by SSS. And then we can claim CP-CTC. We're trying to claim that this angle, DMA, is congruent to BMA. Why? Because they make a line, and if they're congruent to each other, then therefore they have to be perpendicular. We call that a linear pair. Two angles that make a line, right? We call those linear pairs. A line, and there's two of them, linear pair. That's where it comes from. Okay, very nice. Very nice. QED. Quad Eric demonstrator. Oh, by the way, we just proved 513. 513 says that if you are diagonals of just a rhombus, not a parallelogram, but a rhombus, write this down, book truth. The diagonals of a rhombus are perpendicular to each other. But we got to add one extra thing, and that is, well, there's another rhombus that's not called a rhombus, it's called a square. So this is true for rhombi and squares. Not true for rectangles, unless the rectangle is a square. Not true for parallelograms, unless the parallelogram is a square or rhombi. Rhombus, I said plural. Oh, he's doing the chart of death.
I know. Yeah, this isn't fun.
This book loves charts, and the charts are usually the most challenging thing.
I just looking at a lot.
Yeah. This is probably the biggest chart you will do. It's also the one that I'm going to recommend that you put in your notes once it's filled out, because it tells you everything you need to know about quadrilaterals. We okay? 513? All right, 514 says this. You'll prove this one. Each diagonal, not only is it perpendicular, but now we learn that it bisects those angles. So each diagonal, DB, bisects that angle, and it bisects this angle. We don't know if they're congruent yet. AC bisects angle A and angle C. That's what it's basically saying. This is true for all rhombi, not necessarily true for the other special quadrilaterals. But it is true for rhombuses. So therefore it's true for squares as well too. Yes?
You put 1 through 10 all because that's the chart, and then 11 through 12.
Got it. Now it makes sense. If there's one that you're going to forget, it's this one. The rest are, you kind of remember, but for some reason, this one is not memorable. Diagonals only bisect the ones for the rhombi and square. You got a parallelogram, unless it's a rhombus or a square, not true. Got a rectangle, not true. But if the rectangle is a square, true.
I have a question.
Yeah.
So on the chart, it just says parallelogram. But
So just a plain Jane parallelogram.
yeah, but if we're talking about parallelograms, period, then that includes.
Yeah, so they're just talking about the generic one, those 5 things.
Okay,
Opposite sides congruent, opposite
So-
angles.
parallelogram excluding special.
Yeah, we're not going to say it's one of the special ones. We're just saying a general parallelogram.
That
I guess maybe the classic form of a parallelogram that you visually have in your mind.
okay, all right. That clears up.
But you're right. You know, what if the parallelogram is a rhombus, right? Then you can, yeah, but we're going to say no, it's just the classic one. Okay, so we're going to switch gears here. This is a talking proof. I'm just going to talk you through the proof. So this one's pretty nifty, right? We will use this one a number of times in the book. I did pull this one out when you least expect it. All right, a talking proof is I just talk you through the proof. All right, I want you to make a right triangle. And notice I don't say it's an isosceles right triangle. I don't say anything to make a right triangle. So I made a right triangle, X, Y, Z. Okay, this one's a little bit tricky. I want you to make the side XK and KY. So I want you to basically make a quadrilateral. And I want you to make XK congruent to ZY. And I want you to make KY congruent to XZ. See what I did? I want you to do that. So I made XK congruent to this, and I made KY congruent to this. Yes? What is that thing? And what kind of parallelogram is it? Oh, by the way, first off, why is it a parallelogram? Because opposite sides are congruent. So it's parallelogram, and you said it's also a, why is it a rectangle? Yeah, but we never proved that. Well, all we got is one angle, 90. Is it a rectangle? Why is it a rectangle? Well, we just proved in the previous statement that it's a, no. Previous statement we said opposite sides are congruent, therefore it's a, Opposite sides are congruent. It's obviously a parallelogram. So before we can claim it's a rectangle, we only got one angle, but we could use something about parallelograms to get to it's a rectangle. You said that, so if this is 90, then, so we got two, but remember, definition of a rectangle is a parallelogram that has 4 right angles. Well, what about these two angles?
Supplementary.
Because it's a parallelogram, consecutive angles are supplementary. If this is 90, that's 90, and then opposite angles congruent. That's why this is a rectangle. So what can you say about it? It's a rectangle. Okay, so this shape now is a rectangle, yes? Okay. Now I'm going to make a diagonal ZK. See what I did? Suspiciously, I put M there. What do we know about diagonals of a parallelogram? What do we know about diagonals of a rectangle? 2 theorems ago. They're congruent. So if they're congruent and they bisect each other, think about that. These are the same, and they bisect each other. What can you tell me about this piece, this piece, this piece, and this piece? They're all the same. Okay? So in other words, I'm going to erase the blue now. If all of these pieces, I left this one off for a reason, right? Because remember, we started with a right triangle. Now I got my right triangle with this. These 3 pieces are the same. You just proved it, by the way. So here's the thing. If you have a right triangle and you go from the right angle to the midpoint of the hypotenuse, you create 3. That's what theorem, whatever the next one is. What is it? Micah? What theorem is this? Okay. 515. This is only true for right triangles, and you're going to see this one, I don't know, 3 or 4 times in our book. If you go from the right angle to the midpoint of any right triangle, you've made 3 equal pieces. And by the way, that was a pretty easy proof to do as well. Yeah.
Could you call that the median?
We call it the midpoint, right? Median has a different idea. This is median. So if you go to the midpoint of 2 of the sides and play connected dots, that's the median. Oh, I've got to put some words there. A line from the right angle of a right triangle to the midpoint of the hypotenuse is congruent to the 2 parts. That's confusing, right? The picture tells you everything you need to know. But the words are correct. If a line from the right angle of a right triangle to the midpoint of the hypotenuse, it makes 1, 2, 3 equal parts. Except it doesn't say that. It says is congruent to the 2 parts of the hypotenuse. Cool? So those 3 parts are congruent. ZM, XM, and YM are all congruent. Okay, 2 left. All right, 516 says this. If one angle of a parallelogram is right, well, we just proved this in literally the last proof. What is it? If one angle of a parallelogram is right, then the rest of them, so we got a rectangle. Oops, sorry. And we used that in the previous proof. So technically the last one we proved 2 things. This is 516. And then we got one more. And we're done. And then you can work on the table of depth. Okay? All right, last one. Here's what it says. If you have a parallelogram and two consecutive sides, that means one after the other, are congruent, then it is a rhombus. Well, we can prove that. Okay, I'm going to give you a free proof here. Hey, it's a parallelogram, so what do you know about opposite sides? So that's one tick mark, that's a tick mark. Oh, it's a parallelogram, so that's one tick mark, that one, opposite sides congruent. Boom, parallelogram. I'm sorry, boom, rhombus. That's a lot of stuff today. They take all of these, all 6 of the ones that we just did, and they put it all together in one table. That's questions 1 through 10. It's challenging. You're going to have to continually take your hand and go back and forth between the previous page and the page the table is on, so that you read the theorems and you apply it to the table itself. So go ahead and open up your book so that we're all looking at it. To page 187. 187. We'll do a couple of them. Pair up with somebody there. 187. All right, Amaya, pick one, 1 through 10, whichever one you want. Let's do number 10. Her belief is 10 must be the hardest one, right? So number 10 says all sides are congruent. It says check if this is true or false. In other words, put a check mark next to the ones that's true for. All sides are congruent. If you just have a plain Jane parallelogram, are all sides congruent? Yes or no? Okay, no. So it's not true for parallelogram. If you have a rectangle, we're talking about a normal rectangle, are all sides congruent? No. If you have a rhombus, are all sides congruent? Yes. If you have a square, are all sides congruent? Yes. Okay, that's not too bad. That was actually easy. All right, Caleb, you pick one. So well, maybe 9's going to be the hard one. All right. I don't know which ones are the hard ones. All right, so it says all angles are right angles. Which shapes have all right angles? Rectangles and squares. That's it. So put a check on rectangles and squares, and there's your 2 that we did together. Okay? That's how that table is done. I'm going to highly recommend that once this table is filled out correctly, we'll know tomorrow when we go over home, or we'll know on Monday when we go over homework.
All right.
Right? Because by the way, this is due on Monday, since tomorrow is career day. We'll know on Monday, once it's filled out correctly, I don't know, take your phone, take a picture, print it, and glue it to your book of truth. And that way you have a table that tells you everything you need to know about quadrilaterals, right? Other than trapezoids, which we'll get, it gets a whole section to itself, right? Questions? Make sense, Wes?
Yeah.
Okay. All right. That was easy. Yeah, 17 or 18 are going to be a little challenging.
I just kind of winged it on it. I found out one thing, that for 17 and 4, 50, yeah,
That's it. That's the only thing. I mean, it says it's the median, but that doesn't really give us.
Well, it means it cuts it in half, right?
Yeah, we know that, but
and it gives us our 3
So,
parallel lines.
As soon as I saw that, I'm thinking about this one right there.
Yeah.
So we know that this piece, and this piece are the same. So that you have isosceles triangles.
That's what I thought.
All right.
Okay, so then yeah, I did get this.
Okay.
But 18, it didn't seem right because the answer I got was 60. But that for the measure of angle 4, which is what we're calculating. We're trying to find x. But
Well,
I wanted
if you know they're the same, then that means that Ri would be double the other one.
Yeah.
So you times or divide by 2. I'm gonna double GM and set it equal to Ri. In fact, that's literally kind of like what the quiz is on. Just double GM, set it equal to Ri, and solve. That's it.
that's what they mean by median.
Median, it means the middle, right?
I was like, I said median. I was looking to what? It was doubling.
All right, e-learners, any questions?
No,
Cool. How you doing, Jenna?
I'm good. How are you?
I'm not bad. I'm not bad.
I didn't finish.
Okay. Well, you had the whole period, right?
I don't get it.
So which one did you not get?
I just like forgot how to do like.
Yeah, but I'm saying which one did you didn't finish? Which one did you not finish?
I didn't get that.
Okay, so that's 1 out of 8. We'll still pass with 1 out of 8, right?
That one. And that one.
Okay, so 3 out of 8 were the ones you had challenge on. So I think you can still pull C. I think you can still pull C. Or you just left that one blank.
Yeah.
Okay. All right. I will give you 10 more minutes on this, and then we got to call it quits.
Okay.
Okay. All right, Jen, I'm gonna let you go.
Bye.
All right, see you tomorrow. Oh, tomorrow's going to be career day, so we will be sending you guys links via email for the Zoom meetings itself.